Hi everyone, it's Coach Fred, and here we are to do some more logs. And by logs, I don't mean stack logs. I mean use logarithms to solve and simplify expressions. Okay, so I recently went over the properties of logs, and I want to show you how to use those properties to evaluate an expression. So here's a really great example of how I might be able to simplify this in some way. So I can see that the 8 and the x are being multiplied. So if I use the property that expands, I can write this as log base 2 8 plus log base 2 of x. And then I can evaluate log base 2 of 8, which would be 3. So in a simpler way, I get 3 plus log base 2 of x. All right, this one actually happens to be a number. So now you certainly could use what we've been talking about, the definition of a log, to evaluate that. 2 to what power gives you 1 over 16? Or now you have another way. You could expand it and write it as log base 2 of 1 minus log base 2 of 16. Log base 2 of 1 would be 0. Log base 2 of 16 would be 4. And so 0 minus 4 gives me negative 4. Again, you could say 2 to what number, to what power gives you 1 over 16. So just another way to look at it. All right, here I can see that if I have this exponent, I could bring it to the front. So I get the 3 log 3, 9. I know that log base 3 of 9 is 2. So 3 times 2 gives me 6. All right, and here we have a log equation. Looking for structure, this log, I have a single log equaling a single log. They have the same base. So 10 equals 2x and x equals 5. So that's a quick, easy way to think about how you might choose to use these. But we're going to take a step further, and we're going to talk about how could we solve exponential functions that you can't do mentally. So mentally means you can see it right away. Now, at this point, we've been practicing these, and I think you can see mentally that 2 to the 1/3 power would give me the cubed root of 2. You might also see that 81 could be written as 3 to the 4, so this would be so this would become negative 4. Again, that's mentally. Here, 2 to the x, you could change the bases if you can't see it mentally, and you could see then that x has to be 4. What about this? 5 to the x equals 7. 5 and 7 do not have the same base. So what am I going to do here? I mean, could I estimate? Yeah, I guess I could come up with a power. Looks like it might be a decimal that might get really close to 7. But this is a great place where we can use the properties of logs. Now, I want to think about that equation that I just worked with you, we just did, which said log 10 equals log 5, I think it was 5x, and we got x to be 2. Well, when we had log on both sides, we were able to do something with it. All right, so if I have 5 to the x equals 7, and I want to undo the exponent, I can use the log. The inverse of an exponential function is a log, and that's why it undoes each other. So let me go back. If I take the log of both sides, I now have log 5 raised to the x equals log 7. All right? I bring my exponent of x to the front. So x log 5 equals log 7. So now I want to solve for x and divide by log 5. Okay, and so then we've got log 7 divided by log 5. That's calculator ready. I'm going to grab my calculator. These are base 10 now, right? These are base 10. Oops, so we can do log 7 divided by log 5. And that gives me 1.21. So x equals about 1.21. All right, let's try another one. 2 to the x equals 15. Okay, so I'm going to take the log of both sides. I'm going to bring the power to the front using that property. And then I'm going to solve for x. All right, so I'm going to grab my calculator. Let me clear that. I'm going to put in log 15 divided by log 2, and I get 3.91. Okay, I want you to try these next two, and that's where we're going to stop for today. All right, guys, have a great day.